Hi everyone, in this video I would like to explain what you may see in this dynamic figure. And now this is a triangle ABC. We're going to talk about angles inside the triangle and how they may vary. So this is based on a thought experiment introduced by a French mathematician, Alexis Clairaut, in his book in 1741. So inside that book, he's talked about different kind of geometric situations and suggests different ways of understanding the geometric relations and properties. So we go back to this case, we're interested in the angles in triangle, and suppose the angle H is fixed at the beginning and AB is a horizontal line. Let's concentrate on the position of the point C, which you can move it freely on this line away or close to the point A. Okay, so in this way, the angle C will change. At the same time, angle B is also changed. Okay, let's see how the size may vary. So let's start from this position. Okay, notice that the angle C is 62 degrees. If we move it away from A, the angle should decrease. But how? Will they decrease and decrease? Now, if you move it slowly, okay, upward, then you will find that this angle C decreased by 1 degree, but angle B will increase by 1 degree. And if you go on to do this further, okay, you can further reduce the angle C by 1 degree. At the same time, angle B is increased by 1 degree. So you may notice this relation when you further move it upwards slowly, although in some cases there may be some mistakes in the round off. Okay, but generally you can find that how much you decrease the angle C, and then you will see the same amount is being increased in the angle B. Okay, so this comes to an important observations about how the angles in the inside the triangles may be related. So we can further argue why the angle B and C are changed in this way. So you can now add a parallel lines through B parallel to AC. Okay. And here, you can also ask questions. What happens if you continue to move C further away from A? Okay. So in this case, the angle C should be very, very small, right? And angle B will become bigger and bigger. But how big can the angle B be? If you look at this parallel line, then you may reason that the angle B won't be bigger than this angle, okay, formed by this parallel line, okay, and with the horizontal line. So similarly, this angle C, in fact, is also the same as this missing part here between the parallel line. So you may use a pen, okay, to mark it here, this angle and this angle, how they should be the same. So the student may have already learned about alternate angles formed by parallel lines, or without this knowledge, they can still intuitively reason that this angle is the same as this angle. If you notice that this BC, okay, the line segment BC in between, should form the same angle between two parallel lines because the two parallel lines are going in the same direction. So that is also the intuitive argument proposed by the mathematician Clairaut in his book, even without formally describing the angle properties in the parallel lines. So all the arguments based on this experiment is about how we can imagine or how we can relate the angles in an intuitive way first before we go to a very formal proof. Now, finally, so you can print this part, okay, and then go back to the situation, and you can do the same experiment again by changing the angle A to other possible angles, and then explore again whether the same relation between B and C can be found. Okay, so go back to the book, help you understand the ideas coming from the book by the mathematicians, which is published in the 18th century, okay, which is very long time ago already. And also maybe you can imagine that those geometry books at that time mostly present the formal proofs one by one. However, this one is particularly different, okay, because in this case, it mentions a lot of this kind of arguments based on observation and also some kind of informal reasoning. And in fact, he even make use of some dynamic ideas, just like what I show here, even though at that time he does not have this kind of dynamic geometry tools. So which is quite amazing, right, in some sense. So if you're interested, you can follow the links below to find out the original book in the Internet Archive, okay, from the author here. So you can find the few pages I extracted here, or another article from the journals of NCTM, which is Mathematics Teaching in the Middle School. Okay, in this journal articles, okay, the authors introduce Clairaut's ideas and also compare with what we can do nowadays with the dynamic geometry, just like what I try to demonstrate here in this file. So I hope that you find this explanation useful for your understanding of this exploration and ideas.